Start. Hello guys. When I was 29, I am 29. I turned 29. Okay. Good. It was good. Actually, it's pretty good start. Slowly, didn't rush into it. So I hope you stay tuned because I want to work on broad queries with Anaconda Navigator. We have ChatGPT on our side. This will be a crazy research experience. So what I want to do is today is just opening a new chat box. What's on the agenda today? We want to define what a broad query is. So I gave it some thought. What is a broad query? Alright, we had this meeting on Wednesday and everybody was like, Amir, you found this you found these categories. Yes, there are two categories of items in this group and there are two types of users. They are choosing between them. But what is actually a broad query? So let's define that. Because one direction was like, all right, we have top K. If a user comes with a top K click behavior, and can we find these categories based on cascade model? How robust is cascade model, which is called model misspecification? It's pretty good, right? One direction was like, all right, how there, but it was not related like click behavior. It was not related at all to categories. You can have click behavior models on a homogeneous list without having categories of options, and you can say if top K is equivalent to cascade or cascade is equivalent to multinomial logic, or these click behaviors can be equivalent of each other. And I said, right, that's a good question, mathematical, theoretical, but I'm not interested because it's just a theoretical question. I mean, it's probably an applied question too, but it was not the reason we started this. And I was not convinced. And I promised myself I'm not gonna solve a thing about any problem unless I'm convinced about it. But the other aspect of the project, which was more important to us, was this problem of flooding and flea market effect. And I was like, we want to find what a broad query is. So if now we have like two categories of items, two users, then two types of users, we can say, all right, these items belong to this category, these items belong to this category. But in general, what was our main starting primitive goal from the beginning? It was to find what queries are broad. Then it is up to based on click behavior. Then it is up to the platform to find separate those items. That's the second hand thing. So the question is, broad query. What is the definition of a broad query? Let's go with the definition first. So what is a broad query? We have a query like Nike, and it seems once we know a query is broad and like we have the types of users, we can find the users. So let's get okay. So for a broad query, we at least need two categories of users. I don't know, one, two, categories of users. They all search the same query, but they mean different things. And then there are categories of items. One, two, we can say, well, if there are m categories of item as well. right? For example, let's say n categories of items or L categories of items. Why is this here, by the way? All right. Can we come up with a theoretical model? So, and we have some extreme case. Extreme case are actually very important because they gave us a good idea of what we mean. So, what is a simple case? First of all, example 1a, we have like 40% of users type A, right? Which means like shoes or something. And then 60% type B, and then they search the same query, and then we have this list of items, right, that are, I don't know, like for example 5 of them are A, like 6 of them are B, right? That's a that's a basic example. That is the example we were studying so far. Like they were like A, B, B, A, and then N. And then we could say, alright, these are B, these are A. Alright, this is one example. One example that I want to take it to the extreme is, alright, we have, what about the percentage, right? If it is like 10% of the users are group A and 90% are group B, and then we have this query, and then we have like 5A, 6B. Do we want to actually do that? Do we want to say, yes, actually this is a query that needs to be broken down into two groups, even though like almost 90% of our population means B when or A by this query? Where is the percentage? If 99% of the population are saying, yeah, when we search this query Nike, it is shoes, should we show socks at all, or shoes means Nike means shoes? So where is this threshold that we are having? So how extreme we should go? The other one is flooded list. What is a flooded list? So if you have like 40% of our list they mean socks, and like 60% mean shoe, but when they search for query, it is always showing all B, 11 Bs. So 40% of our users cannot click at all. And can we find out if it happened or not? So it's all B. And then, all right, the other one that looks like flea market is like, where is it coming from? It's just, so far we assumed that there are only 2 groups of users. What if there are like 10 groups of users? Can we say 10 groups is actually 2 groups? Is studying 2 groups enough for studying 9 groups? 10 groups, and we say, alright, 9 of those 10 groups are one group and one is another one. So I want to say ABC. What I want to see is like, we have 3 types. A, for example, 30. B, 30. And C, 40. And we also have like a kind of fair list that all of them are present, inclusive. That, like, I don't know, 3 A's, 3 B, and 3 C, right? If I give it, what happens if I feed this click data to what happens if I did this click data to my two category algorithm, estimation algorithm. By the way, for now we can forget the effect of ranking. So Q is like 0, 0, 0, 1. All of them are seen with the same probability. Let's run these experiments. I think they are very insightful. Okay, let's do it. Anaconda. Yale. What is Yale? Not this. Python, right? Research, or what is it? Search. Do I want research or what do I want? Thesis. Cascade. Yes, exactly. So I want to say two-type cascade model. This time I want to make it three types. I need to make change. Can I change it myself or is it better to just ask ChatGPT? So we have no clicks probability 0. That's just any cascade. By the way, we don't need these functions anymore because we are making it. Alright, probability of subset clicked 0 based, then subset getting clicked. This is just once we know the R, so this is simulate cascade session 2 user types 0 based. That's the one that takes R1, R2. Okay. Alright. I can't do it myself, but I'd rather give it to ChatGPT. At this point, so this is my cascade model that users with two types to buy the products how can I generalize the generalize the simulation to the case where we have I don't know, M types of users / categories and N types of users and categories and which which one of user type comes MP1 to PM probability distribution. Perfecto. All right, let's do that. This one is... Let's see how he's doing it. So import numpy as np, this is the same thing. Okay, yeah, because m user type 0 based should have our list instead of our. Oh, those functions stay the same. Alright, perfect. Then we have a p list and then we have a q. This is also a case of model misspecification. Why? Because misspecification. How do they pronounce misspecification? By the way, you cannot unless you're Persian. Misspecific. Misspelled. Do you say misspelled or misspelled?
Misspell.
Misspelled.
Misspecification.
So it is misspecification. Alright. Model misspecification, because why? It is a case of model misspecification. Why? Because when we are generating the data by at least 3 or more, or even 1 user category, and then we are and then we are estimating by the assumption that we have two categories. By the way, on a theoretical level, what happens? Do we merge two categories in one and say now we have two? So it's actually let's take a guess before moving forward. So let's assume we have these three groups. Group A comes 30%. Just we have click here. First one. Group B, like 30% comes to the next three spots, and Group C to the next three spots. How do you think we will categorize them? We say these two are one, or these two are one, or these two are one. And then what will be their relevance? This is very interesting problem. I don't know how they do it in machine learning. Alright, let's see the simulation result first, and then we can talk to ChatGPT if there are works already about. Definitely there are. How can it not be the case? M is len of R list. Type of users. N is len of Q exactly. And len of R and len of R list for okay, for R in R list, it's a list of lists, right? Lengths and R, perfect. P list M, we have M categories, and sum of the P list should be 1. P list must be a probability distribution. User type, and dude, I am learning machine learning as well, as much as I need. For in number of sessions, M equals, what is M? Random.choice M. So we are choosing one of the categories of users based on the P. Then R will be the relevance of that. User type that append M. Session clicks equals 0. Session position clicks are 0. No. J equals 0. And what are these? Are session clicks, and then if it is relevant we will click. If it is less than QJ means we are quitting. Yes. Otherwise we go what about observation problem? Oh, the QJR. I think this part should be the same as the other part. Alright, just let me check these two parts and make sure they are the same. Why there is so much space here? There is no space here. Oh, okay, because I did it. Why it doesn't work? Actually, just simulating, generating the click behavior doesn't need any of it. We just need to generate the data based on those clicks, based on those cascade probabilities. So we don't need any of those functions we have here, like probability of subset click 0 base u. We don't need them, yeah. These are for compute expected click. These are unnecessary. Then we use them for log likelihood mixture later. Probability of subset click UAP. Or no clicks probability 0 base, like after S. This is not necessary in the simulation click. And actually probability of no clicks probability 0 base is just a sub function of probability of subset click 0 base. Exactly. Makes sense, okay. So now, all right, let's go to our simple example. We have the first top three are group A, I give 9. So this should be 1 actually. This should be 1. This should be 1. This should be 1. And this is 9. And this is 1. This is a clean diagonal case. Right. So R is now R1, R2, R3, and Q I want to say it is actually no 0. The percentage I said 0.3, 0.3, and 0.4. What is this? Oh, okay, user type distribution empirical for M. Okay. So I'm gonna so this is the case. We are going to generate the data first. I say it says it is the other two groups. Let's see. What is the difference between clicks and clicks per session? I think it's just the number of clicks. So this guy 3, this guy 4, this guy 4, 3, 4, 2, 5. Some people are 5. Alright, and then so it's type C, type 3, 4 is probably type B. Like this is like 0, 1, 2, 3, 6. What is this guy? Interesting. These guys make situation interesting. So exactly. Now I want to say, what is it? Then we want to say, what is a broad query? What do we do with a list? Like we need to, what is this? Oh, it's just light. Okay. So we are given a click behavior. We want to say beep beep beep. This is a broad query or not? That's what we want to say. We don't want to find the categories necessarily. No, I'm giving just one thing. Clicks positions clicked. Why don't we name them, please? And what is it that you want to say? We want to do it with MLE. not EM. Why? What do you mean N is not defined? Okay, now we need those functions. Wait, this code is getting too big. I need to find a way to manage it. This is scrolling shit. Let me ask ChatGPT. So structure your notebook using markdown headers like 1 sharp, 2 sharp, 3 sharps. Then use collapsible headings to hide sections. Jupyter Lab, this works out of the box. Classic notebook. Table of contents, pane. Jupyter Lab. Oh, okay, we have. Are you watching or not? Okay. RA is 0 0.9, 0 0.1, 0. Again 1, 0 0.9, 0 0.9, 0 0.9. So RA is actually our group B, and group C is also overestimated. RB is kind of the average, 0 0.4, 0 0.4, 0 0.4, 0 0.1, 0 0.1, 0 0.1, 0 0.9, 0 0.9, 0 0.9. So RB is kind of crazy. RB's focus is group C, RA's focus is group B, and group A is not kind of, well, group B is kind of taking it, but not represented in both of them. And Q is 0, 0, 0, 0. It is 0 actually. And P is 0 0.3, which is right about group A or B. So do you think that's something we can say it's a general query? I think because in estimation we don't let Q be 0, right? Yeah, Q is clipped. Doesn't matter, honestly. What about the initial point? There is some randomness involved, so I want to run this part of the code actually again. Oh, random C changes. And there is also one other thing, that what happens E. What happens if it is not a broad query? There is just one group of user, 100%, but we assume in estimation we say there are two groups. Assume. So this time our A got the group A but not B, and group C, but our B is group B. Our B is group B and not the other ones. So you have two vectors. How can you say if there are two categories? And P is almost 70% of the population. Okay. Interesting. I think P is a good factor actually. If there is a P that says like, I don't know, 20 to 80%, then we have a population we cannot ignore. So once you are above 50%, we cannot ignore you. But the thing is that when can we say you are taking over all of it? So if there is a group, alright, let's say that's broad query. Suggestion from one for the broad query and see if it can make sense. Suggestion 1. If there is a group of users whose population PI, I don't know, greater than 10% and less than 50%. Then we have a broad query. Well, what if it is 70%? But other things are. So that's the thing. Either I can say this, or there exist two groups, I and J, such that PI and PJ are greater than 10%. What about that? So there's a well, this one doesn't lead to the other one. We can have a lot of 1% groups. That is not good. That is not realistic too, but like, if there is one group that is between 10 to 50%, and what about other groups? Maybe they are all like 1%. Then the second definition doesn't approve that, right? What about the second? Second one will lead to the first one, right? there are two groups, both greater than 10%. So there is one between 10, greater than 10, less than 50. Because if both of them are greater than or 50, it will be bad. It will be more. Alright, so this one leads to this one. The other way is not true. Maybe we should put this, the definition of our so the question is, if we have two groups that are greater than 10%, what about others? Or 20%? 10 is just a sample number, or a minimum. What about others? Others, when we are categorizing others, what happens? Alright, let's chat with ChatGPT a bit before. What happens in learning? What happens if we generate the data from, for example, 3 groups, but in estimation, assume 2 groups. Well, model misspecification. Through data generating process, DGP has more latent group. These are types 3, and the number of groups you model assumes types. When you underestimate the number of groups, so will we merge 2 groups in one group? Field smear group characterization. What does a smear mean? Coat or mark messily or carelessly with a greasy or sticky substance. His face was smeared, smudged, streaked, stained. Alright. Smears group characterization. When you assume fewer groups than the actual, the estimation algorithm tries to fit the best approximation. You're using fewer components. As a result, the estimation becomes a blend of the true ones, which is happening here. For example, suppose true user types are type A, list top items. Exactly what is happening here. Yeah, you are seeing. So you're not recovering true generative effective approximation. But by the way, we just want to find out if there is something happening. Maybe we can do that, right? Like, alright, it's for now it's good. We put A and C in one group, B and in another group. We don't want to find the categories necessarily. We want to just find if a query is broad or not. Then we can put another team to find those categories. And then A and C also will be separated. No big problem. That's not an issue. The issue is how to define, alright, we have 2 relevance vectors, for example, estimated. What says there are 2 groups of users? So do you say that still in the current one we have 0.9 and 0.9 in the other one, if the difference is like that huge, even though we have elements that are 0.4 in one group and 0.1 in the other. So this is not a huge difference, but 0.9 and 0.1. So we can take, I don't know, the relevance vectors, we can get their Euclidean, the max norm. Maybe that's a good measure. And if the max norm is greater than, I don't know, 0.5, we can say, alright, actually these two are. Bias in parameter estimation. The inferred parameter click bias predicting about clicks. Wrong inference about user base. But we can, I say we can separate A and C later. Lower likelihood and poorer generalization. Easier to explain 2 times than 3 times. Data limitation! Not enough data to estimate 3 times. In this case, your coarser grain model. That's definitely a coarser grain model, but are those two groups separate enough? What can you do about it? Model selection. Use AIC, PIC, cross validation. Okay, what is that? What is AIC, PIC? Cross validation. Diagnostic. Check your residuals or your simulate held out performance to detect. Non-parametric approaches. Use models like Dirichlet process mixture. Isn't it LDA if you don't want to fix the number of types in advance? Empirical suggestions. Try this. Simulate the right frame with the users, assuming 4 types. What is AIC, BIC? Okay, AIC is Akaike information. What is Akaike? Criterion formula is minus 2 log L plus 2K. K is the number of free parameters in the model, like the number of types. Lower AIC is a better model. Likelihood more means AIC lower. Less free parameters is better, yeah. Lower AIC, better AIC percentage. Predicting not necessarily truth. Bayesian Akaike, what is that? How do you pronounce it?
Akaika.
Akaika. What does it mean?
Akaika.
No meaning. Mathematical measure used in a statistical. BIC, Bayesian information criterion formula minus 2 log L k log n. So similar. That was just n log n. Instead of log n, it had 2. Oh, n is the number of data point. K was the number of true prime. Alright, I think this is a very interesting example. Actually, that's a good challenge. What is the definition of a broad query? I like that. How much time? I'm hungry, but there is nothing at home to eat. So I think just let's have this example written down. And we also want to one more thing. We want to add randomness, like statistical experiments. We cannot just run one time and say, all right, this MLE is doing great, or finding the things, the relevance vectors well. It can be just it can be alright, we want to run it multiple times, like this one click session, we generated like 10,000 click sessions, but we want to change, like run this experiment, for example, 100 times. So for now I'm gonna put it there, and then we get back to I don't know, running it so many times. It seems it's doing a good job. So let's go with positivity and trust. And it's again raining. It's crazy, Boston. Alright, but I need to take a break, honestly. Every time I want to write down shit, hurts. I mean, it's ChatGPT writing, to be honest, but still. Hello, sirs. Back. Alright, let's just write this down. Oh shit, wait. very good to know. Okay. Okay. What's going on? Um, so I like to add a section, broad query. So what is a k-mean algorithm? I want to know what is a k-mean algorithm. Because what does it mean? Like you have bunch of points in a space, n-dimensional space. The decision of how many categories or types they have is up to you. You can say, you can be super granular and say there is just one category, like for each data point is a category, or you can say there are two there. Okay. Uh,
Great follow-up. Choosing the number of clusters KKK in k-means, or components in a mixture model, is a classic model selection problem. Here's a breakdown of how to decide on KKK, especially when you have many data points. White heavy check mark 1. Elbow method, heuristic. Plot the within cluster sum of squared errors, WCSS, versus number of clusters KKK. You choose KKK at the elbow where the marginal gain in fit starts to diminish. Procedure. Run k-means for k equals 1 k equals 1 k equals 1 to k max k underscore backslash max k max. Plot. KVS. Inertia equals sigma clusters sigma points point cluster center 2k backslash quad backslash text versus backslash quad backslash text inertia equals backslash sum underscore backslash. Look for a knee/elbow in the curve. Pros, simple and intuitive. Cons, the elbow is often ambiguous, especially with many points. White heavy check mark 2. Silhouette score. Measures how well each point fits in its cluster versus the nearest other cluster. Silhouette score for point 3. S, I, equals B, I, max A, I, B, I, S, I, equals backslash frac B, I, backslash max backslash A, I, B, I, backslash S, I, equals max A, I, B, I, B, I, A, I, A, I, A, I, A, I average distance to points in the same cluster. Pros, works well in practice. CONS, computationally more expensive than elbow method. White heavy check mark 3. Gap statistic, more principled. Compares the WCSS for your data to what you'd expect under a null, random, distribution. Idea, true clusters should reduce WCSS more than random clustering. Choose the smallest KKK such that, gap, k, greater than or equal to gap, k plus 1, s. Choose the smallest KKK such that, pros, more statistically grounded cons, slower requires simulations on reference data. White heavy check mark 4. Information criteria, AIC/BIC, for Gaussian mixture models, GMMs. If you're clustering via probabilistic models, example M for Gaussian mixtures, you pick the KKK with the lowest AIC/BIC. Pros, well principled, gives hard number. Cons, assumes probabilistic model, not available for vanilla k-means. Summary table. Method type best for notes elbow method heuristic quick visual guess may be ambiguous silhouette score metric based compact, Well-separated clusters good for high data gap statistics. Statistical significant cluster validation. Slower AIC/BIC, GMMs, probabilistic model-based clustering not for pure k-means. Would you like Python code to try these methods for a data set?
Alright, let's keep this definition for now. Definitely it is not, it should be edited, but alright. Simplify simplify the rest. Oh, the first. what is the other one I want to say is that's it, right? He really took one. Okay, what else? Are we good? All right, just let's do one more. I want to do one flooded case and see how it does. Then we are good to go. Oh, you didn't show them? Alright, let's do the So, okay, we did this one. Great job. I want to do one that we have one user group, two categories of items, and the other one that we have two user groups and one category of items. Like a threesome, and the other one is nothing. Close to a threesome. So we did D. Alright, we did D. This is great. What is E? So what if it is not a broad query? We have 100% of users, 1, and we just want to estimate with 2. Does this assumption that there are 2 categories ruin our estimation, like the wrong assumption, like a self-fulfilling prophecy? All of them are from one category, but because we are running it, can we get a wrong result? All right, just do it. I won't write it down. All right. Do this, and then I run the functions too. And then I wanna nope. Actually, I'm just using maximum likelihood or like this ML algorithms or optimization as a tool. I love that actually. I fucking love that. Jesus. Multiple user. Can I do just one user type? Yeah. So we have only one user type here. And then we have just our list is R1. And I say 9, 8, I don't know, 7, I don't know, 9, I don't know, 6, I don't know, 4, 6, 9. So we are generating the data from one group and we are removing any ranking effect, and P is like just 100% 1. Dude, this feels so good. It feels like I have a bitch for me who does all the code. This is amazing. And then we get some clicks, and then we want to see what the MLE does for us. RA and RB. Let's see what it says about RA and RB. specification.
Ωραίο αυτοκίνητο αφεντικό.
Maybe we can get the answer that this is not way, or it is something. We need to add some assumption, remove some assumption. But I'm really enjoying it, whatever it is. Or we can find a good problem. Fucking, what is the definition of a broad query? Or they may say we use other methods to find broad queries. Brag. Or we need to add more variables to this thing. You just users click is not enough. How do they find broad queries? That's the thing. That was the question. How did they find that Nikon ZF, for example, was flooded with? So what is this, by the way? This is just. Yeah, this is kind of flooded. It's not exactly flooded. If I wanted to create a flooded case, I would have two users group. Like I wanted just 60% of the users click. Here we are letting 100% of the users click. Yeah, I think for flooded I would build like 60-40, and then for one it will be all 0.9, and for the other one it will be all 0.1. So it's not exactly flooded. Not exactly. Come on. Why is it so difficult, by the way? Difficult. I want to play counter. Come on. Give me the answer. What song is it? Why does it take so long? It's going crazy. Ah, it is supposed to be two groups, so it's just one group. By the way, what was the other question? It was a basic thing that Moser said, that if people are not clicking from the other group, items from the other group, that's actually easy, right? It's not very difficult to just... Yeah, what is the problem, by the way? Why do we let... Is it basic? Is it like we are just doing a theoretical game, or is it... Where is this coming from? I don't like it, actually. It feels like it is just a theoretical trick we are doing, and I don't like tricks. We added it because we had a theoretical problem that, alright, if they are not even clicking from the other category, we just connect the clicks that happen together and they will make the cluster or the category. Why is it taking so long? Alright, I guess. What? What are you watching, guys? This is for one of our supporters of the channel who asked me to play Counter more. Did I have to leave? laptop is exploding. Maybe it is the same category, but it's really like low quality. That is, Jesus. Oh, shit, I don't like that. Oh, I'm back. How does that work? Ah! What was his name? Real noob. Baggage. Let's go. I mean, both of them. Sometimes looks like two mice instead of one mouse. Mouse. I wanna my damn. Where are they? Kicked by server. Why? It's welcome here. No! Don't get me! Don't get me! Don't get me! Jesus. Where did it hit? Alright, this is harsh game. Difficult. A, B, C. Dude, I hit. Bro, fucking character. Ah! I think he's still there. Huh. Where? Oh, dude, come on. From Lincoln. I should not move. That's what I should do. Jesus. Dude, this motherfucker, hardcore, he just targets me. This is fun. Jesus.
Y'all niggas on here is some fucking ass. Alright, you're gonna wanna shoot the bad guys.
Oh, fucking fast. If you're that, this hardcore just fucked me. Got all these weapons by me. Don't kill me, don't kill me, don't kill me. No, don't knife me, guys. I'm not gonna knife you. Abraham, I'm a big fan. Why do you do that to me? Why do you do that to me? Abraham, why do you do that to me? I'm getting knifed here. Let's get back home, guys. Honestly, hardcore gonna knife me. I had this nightmare. A nightmare coming true. La 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 la. La 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 la. Now we have 3 knives, it is getting a lot. Who could have seen this one? Oh my god! Oh my god! Actually, I was better than Abraham. Alright, we are leaving. Lie, 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 lie. Ah, fucking done. Where is it? Where is my result? You fucking ass. See? They are almost the same, actually, alright? The 3 first can belong to both. And then we have, this is amazing. I want to keep this result in my heart. Oh, so this one is weirdly attached. I mean, this is one of those cases that we should do statistical. 6, 4, 9, 8, 9, 8. So they are very close. When they are very close, it means that there is no actually All right. Okay, guys. Goodbye.